Hi guys, this is Bob. Today I'm going to show you how to do a vibrations analysis in SolidWorks. Just kidding, I'm messing with you. This is Grace and Sally, but we are going to show you how to do vibrations in SolidWorks. So let's get into it. So for this study, we used an example that we all know and love, a ski. So we basically modeled this in SolidWorks, added our little logo to it, custom ski made by Grace and Sally. You can see how the thickness kind of varies throughout the length of the ski. We also made this out of polyethylene plastic, which is a pretty common plastic to be used in skis. We modeled this using the flex tool. We won't get into the nitty-gritty of that since we're focusing on the vibrations here, but that's how we made that model.
For our first study, we're going to create a new simulation study. And then we're going to name it whatever you want, but we're going to do the frequency study for this one. And then the first thing we want to do is apply fixtures to our model. And so you can choose any fixture you want, but for this example, we're going to do a fixed geometry for where our bindings are going to be. So we come over here and we select this, and now it will fix it just in that place. Next, we're going to create a load that will represent the skier. So we're going to do a distributed mass over the same area as the bindings before. And we're going to do half of the skier's weight, which would be 60 pounds in this example. Okay, next we're going to create a mesh. And so right-click on the mesh and create mesh. And you can change this depending on the quality of your analysis, but for these purposes, we're going to do a coarser mesh. So that will be faster. This is what the mesh kind of looks like. Next, we're going to edit the model properties in here. And then you can either set it as number of frequencies, but for this, we're going to do an upper bound frequency of 200 Hertz. And we're also going to use a soft spring to stabilize the model. And now we can run the test.
Okay, so now that we've got our simulation run, we can look at a couple of different things in the results. So first of all, I'm just going to go in, hit edit definition, and then we're going to go to chart options and we're going to show min and max so we can see what the minimum and maximum deflection are for our different modes. So I think you guys have all taken vibrations, but basically this is giving us a list of all of the different modes. You'll notice that they kind of come in pairs. So this is, the next mode shape, and then it shows it on the front of the ski and on the back of the ski. So I'll kind of just go through and show you what those different modes look like. And just like some other FEA software, it kind of exaggerates the deformation so you can see the shape of it better. And you can see the deflection in inches over here on the right. Here's this one. And then here's kind of the last shape. So that's what all of those different modes look like. And then next we're going to go look at the resonant frequency of each mode. So we're going to right click on results, and then we're going to click list resonant frequencies. And then that'll just give us this table that shows us a list of the resonant frequency for all of the different modes that were generated for the frequency range that we chose. So you can save that if you want. We're just going to close out of it. And then the last thing that we want to look at for results on this model is the natural frequency of each mode. So we'll click define frequency response graph. And then mode number, totally fine. We're going to hit OK. And this graph basically shows us what the natural frequency is of each of these modes. So the modes are on the x-axis. And then, like, for example, for mode 1, we can see that the natural frequency is about 9 hertz there on the bottom. So that's where you can get that info.
So for an alternate way of doing this analysis, we can do a linear dynamic harmonic analysis. And so we're going to create the simulation study kind of in the same way, but down here in the advanced simulation, you can do linear dynamic and do a harmonic study. And click OK. And then now we're going to do our fixtures and loads the same way as the last analysis. And then for this analysis, we're going to do something different, and we're going to apply a force that will simulate the terrain roughness. We're going to do 20 pounds force. And for this load, we're going to apply it on the bottom of the ski. So you can see here, it's all along the bottom. The next thing we have to do is define the damping coefficient. And so we can just use the modal damping they have here in the simulation. And for a ski, we're going to use 0.03. Click OK. And then the last thing we have to do is mesh it just like the last part. Okay. Now we can go and edit the properties again and use the same upper bound frequency and the soft spring. Now we can run the model.
All right, so once that simulation has run, the first thing that we're going to do is look at this von Mises stress plot that automatically generates. So we're going to go in and edit the definition and change a couple of things. First of all, we're going to switch it to regular von Mises stress, and then we can go into chart options, same as before, add that minimum and maximum. And you can see that the min and the max stress, even the max stress, are really small for the simulation, which makes some sense since we only applied, 20 pounds of force to it. And then over here, you can see that gradient again of that stress. And then you can do a similar thing, go over to this displacement plot. Again, we can go in and show that min and max. And yeah, again, these displacements are really small because we didn't apply that large of a load, which is good. That's what you want in your ski. You don't want that thing deflecting too far. Okay, and then one thing that's different from the last simulation that we ran is that this one doesn't automatically show your mode shape plots. So we can go right click on results and then click define mode shape plot. And we'll leave it on mode shape 1 for now. And then this shows you the mode shape for the first mode. So then we're going to also go in and have it add the minimum, the maximum, and the legend. Okay. And you'll notice here it says mode shape 1. So this is the first mode shape. And then you can click through and see the different mode shapes, kind of similarly to what we did on the first simulation. And you'll notice that these mode shapes look pretty similar to the first simulation too, which makes sense since it's the same geometry of part. And then for this one, we can also look at that frequency response graph like we did last time. So we'll go in here and click define frequency response graph, keep it on the mode number. And again, those mode numbers have about the same shape of natural frequency as they did for that first simulation. And then we can also go in here and list those resonant frequencies again. So same as before, you can come in here and see those. And yeah, thanks very much for listening. Let us know if you have any questions.